Okay, here you have a 40 kilogram ball. Is pulled to one side until it's 1.6 meters above the lowest point. And they want to know what is the velocity going to be as it goes through the lowest point. So here we go. And then we're going to drop it. And we want to know, that's kind of ridiculous right there. We'll stop it right here. What is the speed going to be as it passes through that point right there? Well, there's all kinds of ways you could do it with the old equations you knew, but it's much easier to say that the PEI plus the KEI equals PEF plus KEF. Well, you know if it starts from rest here that it has no KEI. If it swings through the lowest point, it has no PEF left. So MGH, initial, is equal to 1/2 MBF squared. Masses can cancel. So I wind up with 9.8 meters per second squared times, what, Dave? Yeah, doesn't look like much like an E, does it? 1.6 meters is my height initially, is equal to 1/2 BF squared. Multiply this side by 2 and this side by 2. And I'm going to get 19.6 meters per second squared times 1.6 meters. Take the square root of that, and that'll give me my final speed. And someone can do that for us when they get a chance. Okay, so we got 5.6 meters per second. And notice that this really just becomes VF is equal to the square root of 2GH. You saw that as VF squared equals VI squared plus 2GH. Back when we were doing those equations, that was 0. So it's really the same thing. It's just a lot easier to think about it like this because you don't have to worry about what happens as it moves from one point to another. Now let's look at this one. It talks about an Atwood machine. You did the lab with the Atwood machine. Remember you had a pulley here and then you had a mass here and a mass here. Do you remember that? And it was hooked up to the computer. Okay, so this is my 800 grams. This is my 700 grams. And we want to know how fast is 800 gram moving after it's fallen 120 centimeters. All right, so we have KEI plus PEI equals KEF plus PEF. Sorry, Cole. All right, so delta PE is going to be M2GH minus M1GH, or 0.700 kilograms times 9.8 times the 1.2 meters that this one went up, minus 0.8 times the 9.8, gravity, times the 1.2 meters that this one fell. I'm going to stop there. Okay, so I'm going to do that math, but really the only difference is I have 1/10 of a kilogram difference, so I'm going to multiply 1/10 times 9.8 times 1.2. Would you agree? Do you agree that everything here and here is the same, here and here is the same, and I'm subtracting 0.7 minus 0.8 and getting 0.1? So I'm going to get a negative. Would somebody tell us what you're going to get right there? Negative 1.176. To do, well, that change in PE is equal to the change in KE. So I have a negative 1.176 joules is equal to my delta KE. So I'm going to say negative 1.176 joules is equal to 1/2 M. Okay, so I have to think about this. Aren't they both going to move? So 1/2 total mass. 800 and 700 is 1,500, 1.5 kilograms, right? BF squared is what we're looking for. And BI squared is 0 because the system started for rest. 1.176 joules is how much KE was gained. So I'm going to ignore that negative sign because I know it was gained. So now I can take 1.17 joules is equal to half of 1.5, which is 0.75 kilograms, times VF squared. And what am I going to get right there? 1.25 meters per second. Okay. So I think that this is not what we're going to be using for now. We're just going to use conservation of energy. I think it'll make your life a lot sweeter. You would get the same exact answer. I just think this is a quicker process and a lot less apt to make mistakes. Okay, so they got the same thing as us. All right. It says if friction forces are negligible, oops, but I got to show you what's going on with the bead, so let's go back and look at the picture. All right, so here we have a little roller coaster looking thing, and we have points A, B, and C. And notice that they don't give me a mass for the bead. They're going to use a bead here instead of a car. Okay, but notice it doesn't have a mass because the mass is going to cancel out anyway. Okay, so I know that I have a speed at that point, but I also need to know what that y is, so I'm going to have to go back and let the slide finish out for me. So let's go back and get the height. There we go. All right, so let's see if we can work it now. Okay, so KE at A plus PE at A equals KE at B plus PE at B. Now notice I don't have a height at B, so I'm going to call this 0. And I can, because in potential energy I get to set up my own relative things. So if you look at all of that, my mass is going to appear in every one of these expressions, so that's why they don't care how big the bead is. So I have 1/2, the speed at A is 2, plus gravity 9.8 times 0.8 meters equals 1/2 the speed at B squared. And then the height at B is 0, so that whole quantity falls. Okay, when I square 2, I get 4. Half of 4 is 2, so that's going to give me 2 meters squared per second squared. 8/10 times 9.8 is what, 7.84 meters squared per second squared is equal to 1/2 the speed at B squared. I'm going to add those and get 9.84. Now I'm going to divide by 1/2. And that's going to give me the speed of B squared. Well, when I do that math, this gives me 19.6 meters squared per second squared is equal to the speed at B, but I don't want our speed at B squared. I want the speed at B, so I'm going to take the square root of that number. And I'm going to get 4 point what? 43. Thank you. There we go. So I'm going to do the exact same thing. And I'm going to use A and C. You can do B and C. Doesn't really matter. You want to do B and C? Sure, Miss Walker, whatever you say. So let's do the PE at B, which we said was 0, plus the KE at B equals the PE at C plus the KE at C. So I'm going to have 1/2 m, and we said our speed at B was 4.4, equals m, g is 9.8, height is 0.5 meters, and the KE at C is what we're going to try to find, 1/2 m, speed at C squared. Masses will all cancel out. So I have 9.8 over here again, is equal to 4.9 plus 1/2 the speed at C squared. So I'm going to have 9.8 meters squared per second squared is equal to the speed at C squared. Square root both sides. So the speed at C is 3. I want to say 13, but I might be wrong, so somebody better check me. Okay, so I should have gotten 3.13 meters per second for my speed at C. But do you see how much how easier that is rather than doing net F equals MA and fighting all that way through that? Okay. All right. She is on top of things. Okay. So if we click through what they did, they better get the same answer as us, and they do. Big surprise. Okay. Now we need to look at the fact that we had some friction present. All right, so is this the one that's next in your notes? All right, we're almost there. Suppose the bead in problem 6.9 has a mass of 15 grams and a speed of 2 meters per second, and it stops when it gets to A. The length of the wire from A to C is 250 centimeters. How large is the average friction force that opposes the motion of the bead? All right, so I'm going to say that KEI, or KE at A plus PE at A, minus the work done by friction is equal to KE at C plus PE at C. Now, how did I know to minus the work done by friction? Well, it always takes energy away. Always takes energy away. So anything that's left is going to give me the energy at C. So there's all my math, which there's a lot to it. Now I need the frictional force, and I'll find that in a minute. I'm going to find the work done by friction first. So I'm going to take multiply my 2 by 2 and get 4. Half of 4 is 2. 2 times 0.015 is 0.030 joules. Okay, now I'm going to do this one times this one, and I'm going to get 0.8 times 0.015 is 0.012. So 0.012 times 9.8 I think is 0.1176, but somebody better check me. All right, so that's going to be 0.0075 times 9.8. I don't know this number right here. Somebody's going to have to get that one for me. All right, so now I have all my numbers. So I have my negative work done by friction is equal to 0.0735 minus 0.1176 minus 0.030. So my work done by friction is negative, and I'm going to get a negative amount of joules over here. So I get 0.0741. It's negative, which makes sense because friction is taking energy away. So now I'm going to say, well, that work done by friction is equal to the force of friction times the cosine of theta times the distance. So negative 0.0741 joules is equal to the force of friction times the cosine of 180 times, it tells me the wire is 250 centimeters long, which is 0.250 meters. So my force of friction is going to be okay, that'll be a 6.2964, I think, but somebody better check me because I just did it in my head and I might be kind of goofy there. Save this